In this lecture, I will explain a new concept that's to define the new coordinate frame system for the CFX. While we can also define the angle of attack by the cos and sine component as we did in the fluent section, but in CFX you can also rotate your coordinate frame by the angle of attack. So instead of providing the cos and sine components to the velocity vector, you can just put the value of the velocity along the x-axis. That's the case of the new x-axis. And this new x-axis and y-axis, they are rotated by 10 degrees, are the angle of attack we want to simulate in the CFD. And then just provide the single value instead of providing the components of the velocity on the x, y or z coordinate frame if the case is three-dimensional. So this is a very important concept here. So in order to provide this value, we are going to click on the coordinate frame, or you can also right click in the coordinate frame and insert the new coordinate frame. By default, this is the XYZ coordinate frame. This is a global coordinate frame, and this is denoted by the coordinate number 0. And the new one will be denoted by the coordinate frame 1 and so on. So number 2, number 3, number 4. So now click on the coordinate frame, and you can also change the name. If you want to change the name, it's your choice. So let's say if I put the default name is coordinate 1, and I can put the name as the angle of attack of the 10 degrees. So this will be useful to mean that this is the frame where I'm going to provide the angle of attack of the 10 degrees. So the concept is very simple. You have to, first of all, you have to provide the origin. So this origin is going to be at the 0, 0 and 0. That is the leading edge of your aerofoil. Or you can also provide this frame, reference frame at the trailing edge. In that case, the origin will be at the 1, 0 and 0. The second thing is the z-axis point. So that z-axis point can be put anywhere along z-axis, so its value doesn't matter. So you can put the 1, 2, 3, 0.5, 0.1. But the only thing is important is that you should be providing the z-axis point. So if you provide the, let's say 1, 0, 0. Now your z-axis will be along the x-axis in the coordinate frame number 0. So new z-axis will be along the x-axis in the global coordinate frame. So, but we will be keeping the coordinate frames not by rotating and not changing axis from x to y or y to z. So I will be using the general definition of x and y and z axis. So that's why I'm just putting the z-axis point at the z-axis. Just putting the point at the 1 or 2 or 3. This will define from the origin to the z-axis. The third point should be on the xz plane. Since we have this axis is the z-axis, so any point you define here is going to define the x-axis. So let's say if you put the point on the y-axis, now this is going to be your new x-axis. So from here you can see that on the x-axis and z-axis, just put the point here that should be at the angle of attack we want to simulate. So for the cos 10, the value is 0.9848, and for the sin 10, the value is a 0.173648. And applying the right hand rule, and you can define the x and y axis. So you can see if you take the projection of this point on the axis, this is going to define your x-axis. And if you apply the right hand rule, this is going to be your y-axis. And suppose there is a case when the z-axis was defined at the -1. In that case, if you apply the right hand rule, the minus y-axis is going to be your y-axis for the new coordinate frame. This is how we define the new coordinate frame system in the CFX. So just put these values. And the option I'm going to use is the axis points 0, 0, 0. And then 0, 0, 1 and then just get the value of the sine and the cosine. So tan of the cos, this will go to the your first point, and then tan of the sine, the second point, and click on the OK. As you can see here, that this coordinate frame has been rotated by the 10 degrees of angle of attack, and z-axis is along the z-axis of the original coordinate frame. The y-axis is by the green color. This again is a y-axis, but it is rotated by the 10 degrees, and x-axis by shown by the red color is again rotated by the 10 degrees. If I zoom the aerofoil section, so as you can see here, that we have provided the coordinate frame at the leading edge of the aerofoil.